Today we are going to see exercise number 4, statistical inferences. In this f- first question, we calculated the mean or average of each numerical column in the COVID-19 dataset. The mean is obtained by adding all the values in a column and dividing the total by the number of values. It gives us an idea about the central or average value of the data. For example, it can tell us the average number of confirmed cases, deaths, or recoveries. The mean is one of the most commonly used measure of central tendency. In the next second question, we calculated the median of each numerical column and compare it with the mean. The median is the middle value when all the other values are arranged in ascending order. Comparing the mean and median help us understand the distribution of the data. If they are close, the data may be relatively balanced, while a large difference between them may indicate that the data is skewed or contains extreme values. This comparison is especially useful for COVID-19 data because some locations may have much higher case number than others. In the third question, we find the mode for both categorical and numerical columns. The mode is the value that occurs most frequently in the column. It is particularly useful for categorical data because it tells us the most common category. The analysis also check whether any column has more than one mode. If two or more values occur with the same highest frequency, the column is said to have multiple modes. This helps us understand the most frequently occurring date value in the dataset. In the in the fourth question, we calculate the variance of each numerical column. Variance measure how much the value differ or spread out from their mean. A small variance means that most values are close to the average, while a large variance means that the values are widely spread. We also identify the column with the highest variance. That column has the greatest variability among the numerical variables. Therefore, variance helps us understand the amount of variation present in COVID-19 data set. In the fifth question, we calculate the standard deviation of each numerical column. Standard deviation is another measure of how spread out the data is from its mean. It is related to variance because standard deviation is the square root of variance. The higher standard deviation indicates greater variation, while a lower value indicates the observation are closer to the average. The main advantage of standard deviation is that it is expressed in the same units as the original data, making it easier to interpret. In the sixth question, we calculate the range for every numerical column. Range is calculated as the difference between the maximum and minimum values. It gives a simple idea of the total spread of the data. A larger range means there is a great difference between the smallest and largest observation. We also identify the column with the widest range. This helps us determine which variable has the greatest overall spread in its value. In the seventh question, we calculate the interquartile range or IQR and identify outliers. IQR represents the spread of the middle 50% of the data. It is calculated using the difference between the third quartile and first quartile. We then use the 1.5 times IQR rule to identify outliers. Values below the lower limit or above the upper limit are considered possible outliers. This is important because COVID-19 data may contain unusual high or low values that can affect statistical calculations. In the eighth question, we calculate the correlation matrix for all numerical variables. Correlation measures the strength and direction of the relationship between two variables. The correlation value ranges from -1 to +1. A value close to +1 indicates a strong positive relationship, while a value close to -1 indicates a strong negative relationship. A value near 0 indicates little or no linear relationship. The correlation matrix allows us to compare all numerical variables at the same time and identify the pairs with the strongest relationship. In the ninth question, we calculate the Pearson correlation coefficient between two selected numerical columns. Pearson correlation measures the strength of a linear relationship between the two variables. If the result is positive, both variables tend to increase together. If the result is negative, one variable tends to increase while the other decrease. If the value is close to zero, there is a little linear relationship. This helps us determine whether the selected coordinating variables have a positive, negative, or neutral relationship. In the 10th question, we calculate the Spearman rank correlation between two selected numerical columns. Unlike Pearson correlations, Spearman correlations work using the rank of the values and measure whether the variables generally increase or decrease together. We compare the Spearman result with the Pearson result. If both values are similar, the relationship is likely to be consistent. If they are different, it may indicate a nonlinear relationship or the influence of extreme values. Spearman correlation is useful when the data does not follow a simple linear pattern. In the 11th question, we create a heat map of the correlation matrix. A heat map represents correlation values using different shades of color, making it easier to understand relationships. Visually strong positive correlations are represented by one color range, while strong negative correlations are represented by another. The numerical correlation values are also displayed in the heat map. By looking at this graph, we can quickly identify which variables are most strongly correlated without having to examine every value in the correlation matrix. In the 12th question, we create a scatter plot with a regression line for two numerical variables. The scatter plot shows individual observation as points, while a regression line shows the overall trend between the variables. If the points generally move upwards from the left to right, the relation is positive. If they move downwards, the relationship is negative. We can compare this visual trend with the Pearson correlation coefficient. Therefore, this graph helps us visually confirm whether the correlation result matches the actual pattern in the data. In the 13th question, we create a box plot for a numerical column. A box plot shows the important statistical information such as median, first quartile, third quartile, and overall spread of the data. It is also useful for identifying outliers, values that appear far away from the main box, and whiskers may be considered outliers. The box plot gives us a quick visual understanding of the distribution and variability of the selected numerical variable. In the 14th question, we create a histogram for the numerical column. The histogram shows how frequently different stages of values occur. It helps us understand the shape of the data distribution. From the histogram, we can determine whether the data is approximately normal, positively skewed, negatively skewed, or bimodal. A both density curve can help us understand the overall shape. This is useful for identifying unusual patterns in COVID-19 numerical data. In 15th question, we create a pair plot for numerical variables. A pair plot displays the relationship between every pair of selected variables using scatter plot. It also shows the individual distribution of each variable. By examining the pair plot, we can identify positive or negative relationships, clusters, outliers, and possible patterns between variables. It provides an overall visual summary of how several numerical variables interact with each other.